Hello everyone and welcome to a video presentation of the manufacturing process of a fully operational black line following robot. As part of the intensive week course, the students of the Electrical and Electronic Engineering Department of the University of Greenwich were assigned the task of designing, developing and manufacturing a black line following robot, which can also be seen in these pictures. This project could be considered as a successful one, as all of the students were able to manufacture their own robot, while the manufacturing process required a huge involvement and the use of highly practical skills and knowledge from the students. Following up, the next upcoming pictures demonstrate the different steps and stages which were entailed in the build of this robot. To begin with, the first task that the students had to deal with was the construction of this simple 3-element line detector sensor, a sensor which could be also considered as a crucial feature for the success of the constructed robot, as it would provide the valuable input that will guide the robot through the black line. Next up, in this stage of the manufacturing process, and maybe the most important one, the students were required to design and manufacture the controlling board of the robot. This stage was mainly composed of two different tasks. The first one would be the creation of a schematic capture of the controlling board, and then the generation of a PCB layout derived from this capture. The pictures here illustrate both the created schematic capture and the PCB layout. Afterwards, according to this layout, the actual controlling board is going to be manufactured by the technicians of the university. After the board was completed, the next challenge for the students was to drill all the holes where the components would be mounted on the board. This task was a rather difficult one because the students had to be extremely accurate and demonstrate exceptional handling skills and abilities when using the special PCB drill, as the possibility of a mistake which would lead to the destruction of the board was always imminent. This procedure was followed up by the soldering of the components into place, leading to the finalization of the control board. Pictures of the finished board can be seen here. At this point, it should be pointed out that the control board features an 80 Mega 328P microprocessor unit, the same that can be found in Arduino boards, both a 4-pin Bluetooth interface connector and a UB232R USB interface, enabling the robot to be either controlled remotely using a laptop or an Android phone, or alternatively to be coded with a program using the Arduino IDE and operate autonomously, and most importantly, the motor driver microchip which will operate the motors. Eventually, before everything was put together, several tests had to be conducted for the boards and the motors, reassuring that they work properly, and most importantly, using the Arduino IDE, the robot was programmed to perform several maneuvers and ultimately follow the black line. Following up, there is some footage illustrating the functionality and operation of the finished robot.